So welcome folks to our video here. This is kind of the second part of your lesson for Thursday. So in this case, obviously I made the video for page 8 of your toolkit. So hopefully you had a chance to look at that. Again, that's basically what our quiz is going to be for the end of the hour. So I'm just adding a little bit more practice here for you guys because obviously there's only one problem in there really for you to kind of practice and see what it's kind of all about. So as you can see by the baskets out in front of you, again, you have all your shapes, again, that you either cut out or, again, some of you accidentally threw them away, so you'll have to recut them out as needed. But what we're going to do here today is we're just basically going to, again, classify these different shapes based on, again, some criteria. So I'm basically going to give you some problems, and then, again, you just kind of pause this video, practice, and then just kind of check your work. So again, that's kind of on your prerogative. Hopefully, again, you're at least practicing a little bit, so that way, again, you're good to go for your quiz. You won't have all of these shapes, obviously. There's only going to be, I believe, 6 in total for the Venn diagram, but again, you will have like a couple of different options. So like it has the right angle or it has reflectional symmetry. Again, that is going to be like one of them for like the Venn diagram, so just keep that in mind. So again, if you don't want to cut them out or if you just don't really want to do it on the piece of paper and you just want to write them down. Again, I'm just going to go ahead and go like kind of step by step here. It's going to be easier for me to kind of write them down so you can see them. So again, whatever you prefer, again, is completely up to you. So we'll slide that out, then I'll just basically slide in the shape. So I'm going to go ahead and write the shapes here, in this case, kind of across the top. So again, you label them any which way you want. Again, I'm just going to go A, B, C, and then just kind of work down the alphabet with each one of them. So for letter A, we have a trapezoid, and again, these are coming from the actual shape bucket, so I'm just going to go ahead and write trapezoid. The next one, in this case, is what we call the regular hexagon, so that could be B. The next one is what we call a parallelogram, so that can be C. And then D, it'll be, let's see, square. And again, all these coming from the shape bucket. E will be a rhombus. F will be a, let's see, rectangle. We'll have an isosceles triangle for letter G. Letter H will be, let's see, equilateral triangle. I'm just going to abbreviate here so you got the idea, so you don't have to spell them all out. I will be, let's see what we're thinking here, a regular pentagon. And then we'll go with a kite for letter A, B, C, D, F, G, H, I, J. So kite for J. And then we're almost done. J, K is a circle. And then A, B, C, L will be a quadrilateral. And then M will be a scalene right triangle. All right, and the next one will be a, almost done, obtuse scaling triangle. That's our last one, so N will be an obtuse scaling triangle. All right, so got all our options here. Again, how you order them is completely up to you, but just keep in mind the video is going to, again, use these letterings, so just keep that with those. So what we're going to do, again, if you got a spare sheet of paper with you, hopefully you do. Otherwise, feel free to grab computer paper up in the front there. We're going to go ahead and draw a Venn diagram. So here's a Venn diagram for you. And again, this is what your quiz is going to look like. So again, you got your Venn diagram. Again, they don't need to be perfect circles. Just keep that in mind. So the classification for problem number 1, what we're going to write. In this case, the one on the left, we're going to go ahead and write has at least one pair of parallel sides. Well, that's going to be the one on the left there. So it has at least one pair of parallel sides. The other one is going to have at least 2 sides of equal length. All right, so what I want you to do, again, right now is just pause the video. Again, just literally put the shapes, letters in there. That's just going to help you because in this case, again, when you go through these problems, again, you're going to realize that a lot of them have a lot of overlap. So again, you're going to be able to see a lot of them have at least one pair of parallel sides, or they have at least two sides of equal length. So again, just keep that in mind when you're doing them. Again, when you're going through, and then once you got them all, come back, and then we'll again go ahead and check your answers. All right, so welcome back. Hopefully, again, you're able to check your answers. When we're looking at this problem, again, what I always do is I always start with kind of what I know. Again, some people go in order, some people kind of go with what they want. So again, I'll just kind of start in order here, and we'll just kind of work our way down. So the first one, trapezoid. If we're looking here, it has at least one pair of parallel sides, and it has at least two sides of equal length. So some of you will be like, well, isosceles trapezoid, right? Again, you'd be totally correct, but in this case, we're talking about all trapezoids. So in this case, having at least one pair of parallel sides is going to be just falling under that criteria there for that one. So in this case, you can go ahead and put letter A there. All right, and then the next one, regular hexagon. So if we're looking here, the regular hexagon, again, has at least two pairs of it has at least two sides of equal length and has at least one pair of parallel sides. So again, hopefully figure out that, again, obviously these hexagon sides are parallel with some of them, and has at least two sides of equal length. If it's regular, it's all. So therefore, again, we're just going to put letter B in the middle. Parallelogram has at least one pair of parallel sides, has two, so therefore, again, we're good to go with that. And then has at least two sides equal length. Obviously, they wouldn't match up then, so you can put letter C in the middle there. Next one, we got the square, so in this case, again, letter D. Letter D, if we're looking here, square obviously has at least one pair of parallel sides, and it has also two sides equal length. So you can go ahead and put D there. Next one, we're looking at a rhombus. So in this case, again, rhombus has at least one pair of parallel sides, and it has two sides of equal length. So we're going to go ahead and put rhombus E in the inside here. All right, and then for the rectangle, letter F, same kind of idea. Again, these quadrilaterals have a lot of things in common, so you can put that in there for both of them as well. All right, so now we're going to kind of move on. The next one we're going to look at is an isosceles triangle. So isosceles triangles, obviously, they don't have any pairs of parallel sides. Otherwise, again, it would be quadrilateral if we thought about the ideas of them being parallel, so they all kind of interconnect. And then the other part of this has at least two sides of equal length. So since, again, it's equilateral, all sides are equal. So therefore, we're going to put H on the right side only. All right, next one, regular pentagon. This one's a little unique because in this case, again, when we think of a pentagon, we're like, oh, it's got to have at least parallel sides, right? Well, in this case, again, we actually don't have parallel sides with the pentagon because, again, they all kind of curve, or they would all kind of intersect if the lines kept on going. So therefore, that pentagon, what it's actually going to be is it's just going to be on the outside here. So it's going to be with that equilateral triangle. So you can go ahead and put I there. All right. Letter J, that's going to be the kite. So the kite, again, does not have any parallel sides, but it has at least two sides that are equal length. So therefore, we can put J for kite there. Now we kind of get to the last part, so we get to the circle. The circle in this case, again, if we ask ourselves, well, it has at least one pair of parallel sides. Obviously, circles don't have sides. They, again, are round, and they have two sides of equal length. And since, again, they don't have sides, actually, the circle is going to be on the outside here. So we're going to go ahead and put K for the outside. All right, the next one, quadrilateral. So in this case, again, if we're looking here, there's nothing really special about that one. So in this case, I can just put L on the outside there. And then scalene triangle. So again, if we're talking triangle, all different side lengths, and obviously they intersect. That scalene triangle is also going to be on the outside, and that's letter M. And last but not least, we have the obtuse scalene triangle. So again, just the angle measure is different, but in this case, again, it still remains the same. So we can go ahead and put the letter N down here as well. All right, so this is what it should look like with your answers for that one. So hopefully you did okay with that. In this case, again, problem should have hopefully been pretty straightforward. All right, so with that in mind, what we're going to do is we're going to go ahead and do another problem. So you can just go ahead and label this one number 2. So we're going to keep the same ones. Again, trapezoid, regular hexagon, all that good stuff. So again, I'll try to keep that on the paper. Again, just kind of reference it as we go along. So number 2, we're going to go ahead and draw another Venn diagram down at the bottom here. So I'll make this one a little bit bigger, so hopefully it can be seen a little bit better. All right, there we go. So now, in this case, the next one, what we're going to do for the Venn diagram, on the left side, We're going to say has only 3 sides. And then the one on the right, we're going to say has 2 right angles. Or excuse me, has a right angle, I should say. My apologies. So what we're looking at here, again, is the shapes. So again, go ahead and pause. Again, fill these in, see if you get the correct answer. And then come back and kind of check your answers once you're done with it. All right, welcome back. So what we're going to do here is we're going to go ahead and take a look at our first couple of examples. So first one, again, we'll start with is the trapezoid. So that's letter A. So if I'm looking at the trapezoid, again, I'm looking at the idea it has only 3 sides. Obviously, trapezoids have 4 sides. It's quadrilateral. And have right angles. So trapezoids don't have any right angles. Otherwise, again, we'd start be talking in the rectangle phase. So in this case, what we're going to do is we're going to put the letter A on the outside there. So trapezoids on the outside. All right, next one for letter B, we got a regular hexagon. So a regular hexagon has only 3 sides. Obviously, that doesn't fall into that. It has a right angle. Obviously, for this case, the regular hexagon is going to be on the outside again. So therefore, that one falls over there. Next one, letter C, parallelogram. So again, if we're looking at a parallelogram, again, this kind of idea has only 3 sides. It's quadrilateral, again, has a right angle. Obviously, it doesn't, so therefore we can put C on the outside. Next one we got is letter D, which is a square. Square, again, has only 3 sides. Obviously, it's a quadrilateral, so that doesn't fall into it, but has a right angle. In this case, again, this will fit, so therefore we're going to put letter D on the inside there. Next one we got is a rhombus. Rhombus has only 3 sides. Obviously, it's not true. It's another quadrilateral and has a right angle. So in this case, what we're going to do is we're going to say that this, excuse me, my voice is starting to go, have a right angle. Obviously, it doesn't. So therefore, we're going to put the rhombus on the outside. So that's letter E. All right, next one's a rectangle. Another quadrilateral. Obviously doesn't go on the left side. Has a right angle though, so therefore we can put it letter F here. All right, next one we got is an isosceles triangle. So therefore, again, isosceles triangles have at least, or excuse me, has only 3 sides, so therefore that makes sense, but does not have a right angle, so you can go ahead and put G here. Next one, equilateral triangle, H, same thing, has 3 sides, but it does not have a right angle, so you can go ahead and put H there. And then now we get to the regular pentagon. So again, now we're looking at this and saying, all right, well, it doesn't have 3 sides. Pentagons, again, don't have right angles, so you can go ahead and put the regular pentagon on the outside there. So letter I. All right, so next one we got is a kite. Kite is J, so therefore, again, if we're looking at a kite here, again, that's a quadrilateral, so 4 sides, and then it does not have a right angle, so therefore kite can go on the outside as well. So that'll be J. A lot of them on the outside here for this one. All right, circle, letter K, has only 3 sides. It does not have 3 sides, has no sides, has no right angles, so therefore we can put K on the outside. All right, we're almost done here. Got 3 more. The next one is what we call a quadrilateral. So in this case, the quadrilateral, nothing unique about it. Obviously, it has 4 sides, has no right angles, so therefore the quadrilateral can be on the outside. So that'll be letter L. Next one is a scalene triangle. Scalene triangles have 3 sides. In this case, again, they have no right angles. So therefore, or excuse me, pause, time out. So if I'm looking at this one actually does fit the bill. My apologies, and I was just thinking about this. So it has only 3 sides. Obviously, that's scalene, but then it's a scalene right triangle. So therefore, again, since it's a right angle, obviously then it falls under here. I was just thinking a regular scalene triangle, and obviously that kind of went over my head there for a second. And then the last one is an obtuse scalene triangle. So in this case, if I'm looking at an obtuse scalene triangle, in this case, the obtuse scalene triangle will also be just with the 3 sides. So therefore, we can go ahead and put the N there. All right. So with that in mind, again, these are kind of our fittings for those. So hopefully you got these answers. Again, this one's a little bit easier. So it'll be kind of a mix, I think. So it's going to be kind of halfway in between these two. So again, some of them will be a little bit easier. Some will be a little bit tougher. All right, and the last thing we're going to do is we're going to go ahead and do our last practice example here. So again, hopefully this will kind of take us to the end. In this case, again, we've kind of done 4 of them now. So again, hopefully you're kind of like, all right, I got this. I'm ready to roll. So you kind of know what you're looking for with these problems. All right, so I'm going to go ahead and do one more. right, so this one's kind of a fun one. We talked about this actually a little while ago, if you recall. So in this case, the first one has reflectional symmetry, or has reflection symmetry, I should say. And then the other one has 180 degree rotation symmetry. So this one, again, if we were to take this and rotate it so it almost looks like it's upside down, again, that would be our specifications for those. All right, so we're going to go ahead and start. The first one, it says for this one, trapezoid, so letter A. So if I'm looking again for a trapezoid, I'm looking and saying, okay, does it have reflectional symmetry? Well, in this case, again, if I were to fold it in half, in this case, again, you could, again, fold the trapezoid in half and it would look like the other side, assuming that, again, we have the reflectional symmetry piece in there. And then it has 180 degree rotation. So again, if you rotate that trapezoid around in this case, again, what you're going to, or excuse me, good lord, my apologies. Trapezoids, I was thinking isosceles. So again, regular trapezoids here, in this case, obviously don't have reflectional symmetry. And then they also do not have 180 degree rotational symmetry. So therefore, that one for letter A is going to be on the outside. So regular trapezoid, again, obviously will not fit the bill. But isosceles trapezoid, as you can probably guess, will have reflection symmetry because in this case I could take it and fold it in half. It would not have obviously 180 degree rotational symmetry, but you get the idea. All right, letter B, a regular hexagon. So if I'm looking here for this one, I'm saying does it have reflectional symmetry? Yep, because in this case you can kind of fold it in half there for those. And then if I rotated that one 180 degrees, that one again would be right in the middle. So again, you can go ahead and put that there. Next one, we have a parallelogram, so therefore, again, letter C. So parallelogram, this one's kind of unique. So in this case, if I were to, again, fold it across, in this case on the other side with that, obviously it wouldn't match up. We kind of talked about that, I think on Monday or Tuesday, I can't remember, when we were talking about the reflectional symmetry piece. But if you rotate it, actually, 180 degrees, parallelograms actually match up. So in this case, letter C will be in there. Square, this one's kind of easy. Obviously, it has reflectional symmetry, and if you rotate it 180 degrees, that would be, again, in the middle there. So therefore, again, it would have that rotational symmetry piece. All right, the next one we have is a rhombus. So again, if I were to take rhombus and fold it in half, in this case, what you should hopefully notice is, again, they would match up. Obviously, those corner pieces would kind of fold up together. And then it would also have 180 degree rotational symmetry, so you can put the rhombus in the middle there. Rectangles, same kind of idea. Again, you can fold it across and it matches, and also it has that 180 degree rotational piece as well, so therefore right in the middle. All right, an isosceles triangle. So then, again, if we're looking at this and we're saying, all right, well, if I take that isosceles triangle, obviously I can fold it in half with that as well. And then if I rotate it 180 degrees, in this case, again, you would kind of match it up. So what I would say is just be careful with this. And let me check my notes here just to make sure that I'm getting it right. So an isosceles triangle, again, wouldn't have the 180 degree rotational piece. It looks like it would if you like rotate it, obviously, but that would be like a 60 degree turn, and then I think like 60 degrees, and then value a little bit bigger than that. So what we're going to say, it has reflectional symmetry if you were to fold it in half, but in this case it would not have the piece for 180 degree rotational symmetry. All right, and then an equilateral triangle, same kind of idea. Obviously, if you tried to rotate it, it again wouldn't match up if it was exactly 180 degrees. It has rotational symmetry, but it does not have it at 180. So therefore, you can go ahead and put equilateral triangle there. All right, the next one we have is a regular pentagon. So therefore, again, if I'm thinking about this, pentagons obviously have reflectional symmetry. You can kind of cut them in half. But if we're looking at it, again, from a rotational piece of 180 degrees simply, again, it has rotational symmetry, but not specifically at 180 degrees, so it wouldn't match up. So therefore, what you can do is you can go ahead and put the regular pentagon under I. All right, the next one we have is kite. So in this case, again, if I'm looking at a kite specifically, just let me check my notes here as well. So a kite, in this case, again, if I'm looking at it specifically, again, it has a reflectional symmetry piece, so again, you could kind of fold it down the middle, but in this case, again, the 180 degree rotation wouldn't match up perfectly, so in this case, you can go ahead and put the kite, letter J, here. All right, circles, pretty easy, has reflectional symmetry, can rotate 180 degrees, what they're all kind of based off of, so you can put circle in the middle there. All right, quadrilateral, obviously this one's not anything unique. It's reflectional, does not have reflectional symmetry, nor it has 180-degree rotational symmetry, so that can be letter L. All right, and then the last two, what we have is a scaling right triangle. So if I'm looking at a scaling right triangle, again, I'm thinking, again, all different lengths, obviously, so again, that wouldn't probably fit the bill for reflectional symmetry. And again, we already said all triangles don't have 180-degree rotational symmetry exactly, so therefore you can put that on the outside. And then an obtuse scaling triangle to finish it out. In this case, again, will be on the outside there as well, because in this case, again, it doesn't fit the bill for any of those. All right, so as you can see, we have all our options here. Hopefully, again, you did okay with this. Again, we kind of went through 3 practice problems plus the notes on the thing. So again, that's basically pretty much all the quiz that has to offer. So I'm hoping that you should be okay with designating these shapes now. So again, whether you do this with the shapes and the chart, or you just kind of copy my notes as you kind of go along, that is completely up to you. So. Again, if you get done early, the sub probably will maybe hand out, will maybe hand out the review packet starting today. Again, that is not homework. It'd be homework on Friday for you. My hope is, again, you'll be able to finish it pretty close, maybe even get it done on Friday, so then that way, again, you won't have any homework. You just can kind of review with those properties as well. All right, with that, hopefully this answers your questions. Please let me know, again, how things go with the sub. Hopefully things go well. Again, if you have any questions, I'm always happy to answer them for you as well. All right, otherwise, have a great rest of your day, and we'll see you all on Friday.